I got this cool pattern I want to show you. Let's start with 11, add 4, add 1. What do you get? 16. That's a perfect square. Okay, pretty boring so far. How about instead of 11, let's do 1,111 plus 44 plus 1. Well, that's 1,156. Also a perfect square. Okay, let's keep going. Instead of 4 ones, how about let's have 6 ones? Okay, this is equal to 111,556, which is also a perfect square. Okay, so what we're going to show today is that if you add 2n1s plus n4s plus 1, you always get a perfect square. So try to prove this on your own, or you could just watch me prove it. Okay. So let's express these numbers in terms of 10 to a power. Okay, so 1, 1, 1, 2n of these. This is equal to 10 to the 0 plus 10 to the first plus all the way up to 10 to the 2n minus 1. Okay? And we can multiply this by 1 minus 10 to the numerator and denominator. The numerator will simplify to 1 minus 10 to the 2n, and the denominator will simplify to 1 minus 10, right? Nothing changes there. And so we don't have negatives. Let's just rewrite this as 10 to the 2n minus 1 over, let's make it even better, 9. Okay, and then similarly, if we have 4 n times, that's equal to 4 times 10 to the 0 plus 10 to the first, all the way up to 10 to the n minus 1 power. Doing the same trick, we have this term is equal to 10 to the n minus 1 over 9. And don't forget the 4 in front. Okay, so what we want to show is that 10 to the 2n minus 1 over 9 plus 4 times 10 to the n minus 1 over 9 plus 1 is always a perfect square. So we want to show this is a perfect square for all n. Again, you could pause the video and try to finish this, or you could just watch me finish it up. So let's write everything with a common denominator. So that's 10 to the 2n minus 1 plus 4 times 10 to the n minus 4, and then plus 9, all over 9. Okay, so we could rewrite this as 10 to the 2n plus 4 times 10 to the n minus 1 minus 4 plus 9 is plus 4 all over 9. And we want to show this is a perfect square. You might notice we could factor the numerator. So that's 10 to the n plus 2 all over 3 squared. And you might think we're done, but it's possible that this is not an integer. So we need to show that this is an integer. Another way to say that is we need to show that 10 to the n plus 2 is equal to 0 mod 3. Okay, and if we could show that, then we're done. Well, note that 10 is equal to 1 mod 3. So raising 10 to a power 10 to the n is equal to 1 to the n mod 3. But 1 to the n is just 1. Okay, so if 10 to the n is equal to 1 mod 3, then we have that 10 to the n plus 2 is equal to 0 mod 3, as desired. So this is divisible by 3, so when we divide by 3, we still have an integer. Squaring it gives us the number we started with. So we showed that if you add this number 2n copies of 1 plus n copies of 4 plus 1, you always get a perfect square. And in fact, this is the square root of the number, 10 to the n plus 2 over 3. All right, thanks for watching. Let me know if you like this video. I'll make more videos like it. All right, bye-bye.